Hello, everybody. I'm very happy to host you today at the LTS webinar with Kai Kreuzer, who is a Java and OSGI expert based in Germany. Kai holds a diploma in mathematics from the Technical University of Darmstadt and spent a part of his studies at the Imperial College of London. Being a home automation enthusiast since childhood, he is now a founder of openHAB, president of the openHAB Foundation, project lead of Eclipse Smart Home, and co-lead of the Eclipse IoT top-level project. Today, we will have a webinar on the topic Smart Home Reloaded. And just before I pass the word to Kai, I wanted briefly to run through the agenda. You will have an hour of presentation by Kai, and then in the end, we will have a 15 minutes of Q&A session. Now on your screen, you could see the Q&A functionality tab. There is a section in the bottom at the right side of your screen where you can post a question to Kai. And in the end of the webinar, he will answer for sure all of your questions. So now I'm very happy to pass the word to Kai and say thank you so much for agreeing to become our rockstar speaker.
Well, thank you very much for the invitation to the webinar. It's a pleasure to be here and to present. So, yeah, I think you did already a very good introduction of myself. So just maybe a few words on the topic openHAB, which I'm going to present today. So I'm actually the founder of this project, which I started by now 7 years ago in the year 2010. And up to now, it's a long way, but it's really a kind of pet project by myself. So it's a spare time project that I mainly created initially for myself, for my own personal needs, in order to achieve a smart home surrounding for myself. So I want to briefly show you the agenda, what I plan to talk about today. So starting with the motivation history. So what is it all about? Why is smart home interesting at all? Guide you a bit through the general design of openHAB and its core concepts. Then roughly touch all the different kinds of features to give you an overview of what things can be done. Every single feature more or less would require a deep dive and need much more time than we have today. I'll speak about how you can actually get started with the setup, so installing the software, configuring it, and also how the daily operation of it looks like. So I hope you see the screen now. That was my starting slide, and that's the agenda that I just mentioned. So motivation down to operation, and second part of the webinar doing a live demo of the installation. So let's start with the first part. If you look at what is currently offered as smart home off-the-shelf devices that you can get in the shops, you see that, well, the whole market is very fragmented, which by itself is not a bad thing because you have many different manufacturers, products, and a lot of choice that you can buy. But the issue that you end up with is that you have many different smart devices in the end, but all of them come with their own app for your smartphone to more or less configure them and to use them. But they are more or less silo applications in the end, and you don't really end up with a smart home where the things are automated across all your devices are in your home, but you have to be still in the center to actually do the coordination of your things. Now, what is more is that if you look at the infrastructure that is created by that, the normal situation is that all the devices do a hole in your firewall to reach out to some cloud service of their respective manufacturer, which is then needed by the smartphone app to control and access the devices. So for every single device, that is more or less a very logical setup, because that's required by the manufacturer to offer that. But again, for the end user, having tens or maybe one day even hundreds of devices, that's really a nightmare of a situation, because you have so many different holes in your firewall. All of these connections can potentially be vulnerabilities. All your data is sent out to the internet, to different servers. You need credentials for all of them, and so on. So it's really not ideal. About the problem that you have silo applications, there is a trend in the industry now to say, well, that's fairly easy. We have standards on the web. We have HTTP, REST APIs, JSON data structures, and so on. So it's pretty easy to actually combine the different services on the cloud level. You can think of stuff like Alexa skills. It's such a kind of situation. You have the Google Home Actions or Works with Nest program, which existed early on. Services like If This Then That, which automate everything on the web. So all of these are within the same category, saying, well, it's fairly easy to actually interact with these devices on the internet. But the issue is more or less that, well, there is no cloud. There are just other people's computers. And so for having, for example, a motion sensor from one vendor and a light to be switched by it from another vendor means that you're now dependent on 3 different parties on the internet and their servers just to switch a single light. And that's definitely not ideal. And if you look at these servers, there can be issues with them. So you really have a dependency for very basic functionality in your home on the availability of these servers. And we've seen that regularly in the past months, that something doesn't work there. So if it is down, okay, you can't switch the lights anymore. You have situations where we've seen that Amazon services went down, so whole categories of applications went down because they all relied on Amazon services. There are also situations where the servers are too easily accessible, actually, because hackers can get into, steal your credentials, steal your data, and so on. So that's also not good. And other situations that we've seen last year where actually the internet itself wasn't available because of distributed denial of service attacks on DNS services and so on. So you have a lot of potential issues there if you're fully reliant on the internet and on different servers from different vendors on that. And that's why I would say all these current infrastructure shouldn't be really called smart home stuff. It's rather connected home. So all of this stuff is really connected to the internet, to the outside world. And to come to a smart home, from my perspective, the logic and the communication should really be locally within the home. And the term smart home has the 2 words smart and home. And thus I want to put an emphasis on the word home here specifically. And that's really then the core idea of openHAB as a project, to actually translate the IoT not to the Internet of Things, but to the Intranet of Things. Because in your home, you have your router, you have your local network, you have your smart home devices hooked up to the local network. And that's really the place where they should communicate, where they should keep the data, and where you can keep things under control. Now, openHAB is a pure software project, so you need some piece of hardware to run it on. in this picture here, it's a simple Raspberry Pi. Any kind of single board computer will do. Another very popular one is, for example, this Pine 64 board. And this one, for example, I also have a lot of home area network radios on. So I have a board here for an ocean radio. I have one for Z-Wave. I have one for Wi-Fi and Bluetooth. So you can have all kinds of different radio technologies and protocols supported from this single gateway on that. Now, openHAB itself, as I said, I started it as my private hobby project, but by now it's a huge community of developers who are working on that project. So last statistics are that there are around 640 different people that already have contributed code to the project. We have, in average, around 200 pull requests being processed and merged every single month. And the user base, I don't have detailed numbers on that because we're not tracking our users, but it's far beyond 100,000 users on the project. And also on our community forum for discussion, for helping each other, there's a lot of traffic, a lot of activity going on with more than 6,000 posts every month. People helping each other, asking questions, and coming up with cool new ideas. So let's have a look at the core concepts of openHAB. So one term that you should know is the one of an item. Items are actually used to define a modeled world of your home. So it's really a functional view, an object-oriented view on the things you want to automate, the things you want to take control of. And an item is more or less the finest granularity of your things. So of something that you want to measure, that you want to control. And such fine granular items can be grouped into group items, into higher level objects then. So in this example here, you see that, well, we have modeled a window to the south of a room, which has some information about off, open 60%. So that would actually here in that case be information about is there an intrusion alarm? Is the window currently open or closed? And is there a shutter which is open or closed or somewhere in between? Another example is in the kitchen, you can have a fan that has a rotating speed that you can turn on and off. And you have a temperature in your kitchen as another item, which is a piece of information. And the kitchen then itself as a room can again be a group that groups other things together. And this is really the view where you're not having devices that are connected necessarily, because your window itself isn't connected, but it's really the thing you want to talk about. Now, for such an item, you define a unique name, which you can use in any textual representation, like in rules on text consoles and so on. You can give it a label for user interfaces. You can have a category to have a suitable icon for it. And most importantly, every item has a state that can change and where it can react on changes. Additionally, it has a list of accepted commands. So you have a certain set of things you can ask an item to do. There are different kinds of items. So basic things like switches, contact, which is open, close, a number, which is usually for temperature values or any kind of measurements, color for color, lights mainly, call for having our telephony features, shutters, location for geolocation stuff, date, time, string, more as some primitive types again. So it's a mix of kind of primitive types and smart home specific stuff already in there. Now, next to the functional layer, there's the physical layer. And that's actually the level where we're talking about things. And these things are more or less the entities that you're adding to your system, that you have to configure, that you have to set up, and which in the end are the technical part to make your smart home a reality. And as I said, on the item, on the functional side, we have a window, while on the things side, we now have, for example, the magnetic contact that checks whether window is open or closed. We have the actuator that can control the shutter and stuff like that. So these are really the two different levels, and every single thing can now expose different functionality through so-called channels. And these channels are then on the same granularity as items, and you can simply link them to icons to say, well, this channel of this specific thing is now the one that should actually be connected to my item and fill it with content, receive the commands and process them, and so on. So that's really flexible, that you can change your hardware, you can link something else to your item, and really replace that without touching any of your functional setup. Now, I already mentioned that this off within the window is meant to be an intrusion alarm. But first of all, it's just a switch item, which means we only have the information it's on or off. And only the user or the administrator himself knows that it should be an intrusion alarm, so he can use it in rules and so on. We're currently working on a semantical layer on top of the functional layer, which brings that kind of information, that this is an intrusion alarm, that the other group is a window, that we have another group for the room, to make that more or less machine readable by adding specific tags from an ontology on top of that. And this will then enable us to actually define rules that can be easily shared between different users, which can automatically retrieve such information. So you could have an alarm rule that automatically listens to all items that are tagged as an intrusion alarm and stuff like that. So really, instead of having it implicit by setting up the items by an administrator, to have it explicitly marked for machine readability. That's something that you will see in upcoming releases. We are currently there at a very initial stage of support for that feature. Now, looking at these two or let's say three layers, all the things layer is really only meant for administration, so initial setup configuration. Once you've done that, you're really only looking at the functional side of things. So the daily operation, or defining your user interface, what you want to show there, automation rules, what should happen, all of that actually works on the functional layer. Now, the next core concept that you need to know is that, well, I call it the Hollywood principle here. Don't call us. We are not defining a protocol that you have to speak and to use in order to be compatible with openHAB, but we call you. So whatever you as a device offer as an API, as a means of communication, be it a serial port with a proprietary protocol on that, be it some standardized radio protocol like Zigbee, be it some IP-based REST API specifically. So all the different things that are out there on the market, we want to support by adding specific logic, specific drivers to support these. So that's then more or less the abstraction that we are doing on top of that, these modules, these drivers are called in openHAB bindings. So we have bindings for example, here Philips Hue, for Sonos speaker, for Wemo, and many, many more things. They talk a proprietary protocol to the devices, but on the openHAB side, to the internal event bus of openHAB, we send state updates, we receive commands in a uniform way. So that's really an abstracted layer where you don't have to know what specific implementation is underneath. Now, this abstraction layer is used then to populate an item registry, which actually keeps track of the current state, which can then be used by user interfaces to show these states, by automation rules to react on these states, and yeah, do all kinds of things there. The next concept to mention is that of sitemaps. So the idea here is to have a declarative approach to define your graphical user interfaces. So you have an easy way to textually describe the content and more or less the widget type, whether you want a slider, drop-down boxes, or whatever, in a textual file, but you're not defining exactly how it should look like with which colors and so on the screen, because that is then left to the user interface implementation. And the idea is really to say, well, you define all this content only once, and on all kinds of different user interfaces, be it for smartphone, for tablets, for web browsers, for bigger panels, all of that can be left to the implementation of the UI, how that is rendered in the end. On the lower right here on the slide, you see the different widget types that exist, like, well, showing text, switches, selections, images, videos, maps that you can see on the screenshot here, and a couple of things. So we try to focus on a small set of widgets because every new user interface that is being built will have to support all of that. So the fewer there are, the easier it is to come up with new UIs on top of that. Okay, so next is the feature overview. First of all, I'd like to mention that openHAB itself, it's really a whole ecosystem of many, many different GitHub repositories with all kinds of different code inside. So the main stuff, and the one I'm going to talk most about from now on, is really the software for the gateway, so for the single board computer itself. And this is really the main project which is there. We have different kind of packaging formats on that, dependent on where you want to install it. So there are Debian packages, Docker images, packages for Synology, and so on. And all of these are different repositories again, which deal with all these specific packaging. Now, we also have repositories for native apps for the smartphones, for Android, for iOS. So there's one for Windows 10, so you can run it on a PC or on a phone likewise. There is another project which is actually a Node.js application, openHAB Cloud, which is software that you can host yourself on some cloud service, which enables you then to remotely access your local instance. Because when you're not at home in your own network, you certainly want to have access remotely to it. And this project really allows you to do that easily in a pretty secure way. The openHAB Cloud is also then used to interact with other cloud services where you don't have any chance to communicate locally. Like we have a project for an Alexa skill that allows good integration there. And we also have an integration with IFT, if this then that, so that openHAB is available as a channel there to use all the things of IFT for the users that like to do that. Okay, so that's just an overview of all the different parts that exist there. Looking now closer at what's actually on the gateway side as the main project. So here you see an architecture overview, which gives you an idea of what different parts and what functionality is in there. So you see this blue bar in the middle, the functional abstraction layer, which is more or less our event bus. Everything south of that, the things binding API, this is really what we've seen, the different bindings to attach new kinds of devices and support them. In order to implement those, we already ship a couple of libraries that are useful, like UPnP discovery, MDNS or Bonjour service, so that you can also use all of that pretty easily if you implement a new kind of support for a certain device. Now, on top of that abstraction layer, you see more or less 4 functional sections. The first one, rule engine, it's really all about automating things, because in the end, for a smart home, things should happen automatically. You don't want to run around with a remote control on your app, more or less. Another part is voice enabling, which is also pretty interesting today to many users, which covers text-to-speech, which is very nice for notifications in the home, speech-to-text for text recognition to do something, human language interpretation for really getting a sense out what people said. We see that in more detail a bit later. Persistence is everything about storing or further processing the events of your devices, like state updates or commands that you did. So to save that in a local database, to send it out to the cloud or something. And the fourth block is the graphical user interfaces that we've seen. So you can have special charts, icon sets that you can hook up there and other stuff. And on the very top of this diagram, you see a REST API to expose the functionality of openHAB to external systems so that openHAB itself behaves nicely and can be integrated with other stuff very openly. Now, looking into the details, the integration bindings, this is here just a rough overview of things that are already supported. It's, I think, around half of what actually exists as bindings. So we have more than 100 different bindings available for openHAB. Some of them support a single device. Some of them, like Z-Wave, support hundreds of devices at the same time because they're doing the same protocol. So there's a big range of different levels of bindings here. On the automation side, there are actually 2 ways how you can automate: completely textual, more for tech-savvy people, but very powerful because you can really do scripting, programming of all you want to do. And we have a new UI-based automation rule where you can click your stuff together to have really simple use cases covered very easily. And both rule engines are actually extensible through certain actions, which is again something that you can add to openHAB. And there are actions for notifications, which is very common for sending emails out, sending tweets, doing MQTT integration, having overlays shown on your Kodi while watching TV and stuff like that. So many different options available. On the user interface side, we have mainly 2 UIs for administration. The one is Paper UI, the other one is Habmin, which focuses more on all Z-Wave users because there's good support on checking your mesh network on Z-Wave, for example. On the Operational side for the user interfaces, there's really a big range. I've mentioned already the native apps for Android, iOS, Windows. We have a Pebble app for a smartwatch. We have different web UIs, the classic UI and basic UI. We have a specific one called Hub Panel, which is meant for tablets that you hook up to your wall as really a control panel that is always on. And so really a big choice for different kinds of use cases. For the audio and voice support, openHAB comes with a concept of audio sources and sinks that you can connect and more or less pass audio streams between them. And audio sources can be local microphone or microphone in some remote device. It can be also an MP3 file on your file system if you just want to play some sound, like a doorbell sound, for example. An audio source can be a text-to-speech engine where you're just feeding in a string and which provides you an audio stream out of that. And as a sink, you can then stream this audio to all kinds of devices that support being a sink. And we, for example, have support on Sonos speakers, on AVRs of Denon, Onkyo, different ones, Chromecast devices, squeeze boxes, and yeah, really more or less everything where you can output sound. Now, for specific text-to-speech implementation, which is, as I said, quite nice for notifications. We have implementations for using Mac OS built-in text-to-speech, which is quite powerful. We have a pure Java open source implementation, Mary TTS. There is a cloud-based one which gives very good results and which is free for personal use, which is Voice RSS. Which also supports many different languages. So there's also a huge selection of what you can actually use. On the speech-to-text side, to actually do voice recognition, that's a bit harder, and there's actually currently progress going on. We have an offline speech recognition called Pocket Sphinx, which is currently in the works, which works pretty nicely if you have simplified vocabulary. So turning things on and off and having such kind of use cases for your home control, that works offline. You're not having to stream anything to anyone on the cloud, and that's really a very nice feature that will be coming soon. For really having recognized strings and then processing them to know what you actually want to do. So switching something, what kind of event do you want to have some information back? This is done through the so-called human language interpreters, where it's also a pluggable concept in openHAB. So you can actually write your own rules where you get the raw recognized string into it. And you can then decide what to make out of that, look for certain keywords and derive some action from that. And yeah, this is open to do further things. You can integrate that with vidAI and other web services, which can provide you such functionality. Just a brief word on the persistence. I already mentioned it's either local databases or sending it out to the cloud. So we actually have 3 different levels of persistent services. Some that only write the data somewhere to a cloud service, to a local log file. Next level that can read more or less sequentially written stuff back, which is mainly useful for rendering charts and stuff like that. So we have RD4J, InfluxDB, DB4O available as implementations. And then we have, as a third level, more or less full database support, where you can also write data somewhere in the middle, or so older data. You can modify stuff, delete stuff, and so on. So that would be a use case for really having a MySQL database or H2 or anything like that underneath. The REST API, as I said, it exposes the functionality, and it really more or less exposes all that openHAB has to offer to the outside world. So it's really, really powerful to integrate with other things you might have around. The REST API is additionally coming with server-sent events, so that we can also push out events to subscribers, so that you don't have to pull on the REST API, but you can really subscribe to stuff and be immediately informed if something happens in the openHAB system. You can also add your own REST endpoints if you want to develop something specific, so it's easily extensible there, and all of the existing user interfaces actually also use the REST API for the communication. If the REST API isn't good enough or too openHAB specific for an integration with something else outside, we also have the possibility to have custom integration or custom exposure to the outside world for specific systems. So we, for example, have one feature which is called Philips Hue emulation. If you install that on openHAB, then openHAB itself claims to be a Philips Hue bridge. So the ones who know the Philips Hue lighting system, it's a small gateway which controls then different bulbs from Zigbee Light Linker protocol. openHAB claims to be the same, and everything that is connected to openHAB can then be accessed that way. And the nice thing is that Amazon Echo as well as Google Home, they both can discover local Hue bridges in your network and control the stuff that is attached to that. So by that mechanism, by having openHAB claiming it is such a bridge, you really have a huge support of different things directly into Amazon Echo and Google Home in a very easy way. In a similar fashion, we also have a HomeKit integration and also some other applications that treat openHAB as a subsystem for their own system in the end. So quite a powerful concept. On the installation side, what you need to know is that openHAB itself is programmed in Java. So all you actually need to run it is a JVM, a Java virtual machine with around 256 megabytes of heap available. And so you really have the full choice of running it on Windows, Mac, Linux. Very popular, as I said, are the single board computers like a Raspberry Pi, which are even with only 512 megabyte of RAM is pretty good device and capable enough to run openHAB. The simplest form of a distribution that we offer is simply a zip file with a start script, which you can launch then, which starts up Java and the container of openHAB. But we also, as mentioned before, have specific packages for Debian so that you can use apt-get to install openHAB that way. Special packages for Synology and QNAP NAS systems. For the new Ubuntu Core operating system, we have a snap package that can be easily installed there. And another very, very neat feature is openHABian as our own Linux distribution for Raspberry Pi and the Pine 64, which means you can just flash an SD card with that image, you put it into your computer, it boots up and does all the installation fully automatically and sets it up for you in about 20 minutes time. So that's very convenient to be easily started if you don't have an operating system at hand already. On the configuration side, again, here we have the textual configuration for tech-savvy people, very powerful, and you can version your stuff. You can easily edit, copy-paste things. So many users prefer that way of setting up openHAB. But we also have a UI-driven way to set up your system for the people that don't like to deal with the text files. That's the Hapman one that I mentioned. So 2 different UIs actually to do that stuff. On the operation as an administrator, you more or less find that openHAB comes with 3 different folders. The one is really the runtime itself, all the binary files, which you don't have to care about at all. Another folder is the conf, where you have your textual configurations stored inside that you can version and control. And then the last is the user data, where you find all log files, all dynamically written data, the database files, everything you might have done as a configuration through the user interfaces, and so on. And as an administrator, it's also very nice that openHAB uses Apache Karaf as a container to run inside, because Apache Karaf comes with many nice management tools. So you have a very powerful shell where you can interact with the system. You have remote SSH access to it, and a lot of other things on that. But of course, the normal interaction on a daily operation is for the end user, not for the administrator. UIs, as I said, are the most visible interaction, but not really the one that is the main or the most important one on the long run when you use your smart home. It's much more important that you have notifications, for example, through text-to-speech, push notifications on your phone or different things, that you can talk to things, that you're informed. And so all of these other mechanisms of interacting with your home are usually more important than the user interfaces themselves. Okay, enough of the slides. So let me now switch to my desktop. And I've actually prepared here the very latest today's snapshot build of openHAB 2.1 that you can download from our website. And if we go into that folder, we can list here, and you see the folders that I mentioned: conf, runtime, user data, the start scripts. And let's go right away here. We call start. And on the very first time, it first has to set up the system. So it takes a little moment before something happens here, but that shouldn't be too long. Meanwhile, I can start my web browser here. Okay, so there we go. It has started up. We can have a look here, for example, listing all the bundles. I didn't mention it yet. openHAB is not only based on Java, it also uses OSGI for the modularity of the things. So here you see directly all the list of the different modules within openHAB, everything that is installed. And so you have full access here. We can now start the log file here, do directly logging to the console, and we see the dashboard has been started. So to connect to it now, we can simply go to our local host, port 8080, local host because I launched it on my computer right here. And we are welcomed now with an initial setup page where we have the choice of different packages to select from. So if you need a description of what this is, you can click here directly. You will get some information on that. For today, for the demo, I'll simply use the sample demo setup because that comes already with some textual configuration files and so on. So we can directly dive into that and look how they look like. Now it starts installing everything that is within that package. We can have a look at our console while it's loading, and we see something's already happening here. So it created already a couple of items. Stuff is being installed. And coming back here, we see that we have now a couple of user interfaces available. Let's start with the paper UI. As I said, that's the one for administrative purposes. we get here, we see it has already discovered stuff on my local network. We come back to that a little bit later. On the add-ons tab here, we now actually have the choice of selecting the bits and pieces that we want for our own installation. So most interesting might be the bindings tab here, which really lists all the different bindings that are available. And you see at the scroll bar here, it's really a long list of things. Let me just install an additional one here. Okay, there we go. We see we already have a new inbox entry. So we installed this binding. It was directly there at runtime, and it already started discovering stuff on my network. And we see we have something more in the inbox here as devices now. So it's really pretty easy to add new things. And as everybody has some other stuff at home, you really have to pick and choose what's the relevant stuff for yourself. On the MISC part, I would like to install here the graphical rule engine. So that's there as well now. On the voice, I just want to install the macOS text-to-speech service. And so yeah, you have the different categories and can install the stuff here. Let's have a look at the configuration. So on the system configuration, we can now, for example, choose where we want to, per default, send audio to. Web audio means that you somewhere have a web browser open to which it will be streamed. So that's now the one that I'm using here. You can choose your locales, persistent service, the voice, as I've installed a text-to-speech service. I have now all the different voices available here. Let's choose an English one for the demo. So we can save that setting. And yeah, that should be the most relevant things to set up here. Let's have a look at the inbox. So we've seen different things on my network. The LiveX one I've just added, which is actually this little bulb that I have right here. It's a Wi-Fi connected bulb. And we can now simply say, please use that. We add it as a thing and show it here. And we see it offers different channels, actually 4 of them. And we can now decide which ones do we actually want to use. So you can say this one is not interesting to us. Infrared, that's a very special one here where you can also light up a dark room so that people don't see it, but webcams can see it, which is quite a neat feature of that bulb. But let's say we remove that. And so now we have only 2 functionalities left, choosing the color or alternatively a color temperature. If we go to the control panel, we see up here, there is the stuff. And if I show the bulb here, I should now directly be able to control it. Yeah, that's fairly easy. The brightness. We can choose color temperature, being a cold white and a warm white. So yeah, full control of that one. Very easy. Let's add some other device like Sonos speaker, which just by chance I also have right next to me. Let's add this one as well and check on the control panel. We see it's directly available here. We can start the music, which you might hear. We can switch to the next song. Does it? Yes, usually it does. Probably just escaped my... Okay, let's leave it here with that. So you can integrate that, and you see many other things here which actually came from our demo setup already. So that was the purely graphical way of adding new stuff to your to your system. Let me now open the Eclipse Smart Home Designer, which is actually the tool that supports you on the textual way to interact with openHAB. That takes a moment. It's more or less an IDE, which comes also with full IDE support, like syntax checks and so on. So we have seen, ignore that one. We have seen, or we can see here on the Things tab, besides our LiveX and the Sonar speaker, we have Astro information, we have an NTP service, we have weather information, and all of that is actually defined in this Things file, and just a single line for all of these things. So we're saying we're defining weather for Berlin, which has a specific location, which is a WOEID, which is required by the Yahoo Weather Service. For sun information, we're just putting a geolocation in here as a configuration. For NTP timing, we just provide a server, refresh times, and so on. So that's the textual way how you can set up devices. Now, having these things, looking at the items, it's also usually just a single line for each item that you want to define for yourself. And demo setup comes really with a whole house being modeled here, having the different floors, first floor, ground floor, cellar, a garden as groups, having then different rooms modeled here, like the living room, the kitchen, which are then assigned to the ground floor in this case. So that's how you do group assignments of items. There are then single fine granular items like single lights, in this case, like heating control, roller shutters. And yeah, you really set that up once, you model all your stuff. And you can also do more powerful things like saying you define a group of all your lights, and this group itself should derive its state from all its members. So if you have 5 lights and one of them is on, then you want to do a bool or combination and say one is on, so my group is on. So you can immediately say this item, if you show it somewhere in the user interface, you see that somewhere in your house you still have a light on. So that's quite convenient, and you can do all of that with a single line of configuration here. Now, on this one here, you see something more. We've modeled a number item for our weather temperature, for outside temperature. And here we do actually the link to our channel of a thing that we've defined. So we're referencing Yahoo Weather Berlin, which we defined, and the channel of this thing is temperature. So this is how we can do a link in a textual way. And by that, our weather temperature is automatically filled by that binding. You see the same happening here for Astro and for NTP down here. And many of the others simply don't have any link to any hardware or binding here, but are just a model. Now, based on these items, we can have a look at the sitemaps. And let me start here just with a very simple one of the demo one. So I reduce it to that. We can simply say we have a sitemap which has a frame with 4 entries, which should be our different floors or the garden of our home. So using that information, if we now go to our operational UI, which is the basic UI here, you see that this now exactly renders these 4 things, and well, it's also changing the layout if we're reducing the screen size. So that's exactly, if we put that side by side, exactly what you see here. And the nice feature about referencing group items is that if you're not providing any further detail, you can now directly drill down here and you will automatically see all the children, all the members of this group. So we can drill down here, we can switch something, do something, roller shutter and so on. Yeah, So all of that is available here. For having more fine-grained access, I'll just put back what the demo comes with. We're now doing a refresh after that one has been saved and reloaded. There we go. Now all of that is directly available. We see there's another frame for weather information. We see that our outside temperature is filled with a value which comes from the Yahoo Weather Service. If we click here, we didn't store any data yet, so we don't have a chart available. We have the astronomical data, which is calculated for the geolocation that we've set. And here you can see other kinds of widgets that are available, like having maps for locations included, having sliders available, different kinds of selections and so on. So all of that can be done here. On another feature, the persistence that I mentioned, that's also easy to define textually, where you can actually now say which items should be persisted in what way. So what we did here is that demo switch, number of lights, and all our heating things should be persisted on every state change, additionally once every minute, and their last persisted state should be actually restored at startup, because otherwise, if we start up our system, we don't know any current state. So quite good approach here is to say, well, let's take the last one that has been persisted. We can have different strategies for others. So that one just goes once every minute, not every change. And by now, a minute should have passed, so that we can also see that, yeah, oops, that we have a chart here. There's some refresh issue as it seems, but you see the chart that it's now starting to get the data of that. Okay, so that much about defining your UIs, getting all your information set up. Now let's have a look at the automation side. Let's start the demo rules, and there, there's some issue as it seems with the designer. Let me restart that quickly to open that file. Okay, let's see if we can now open the demo rules file. Takes a moment. That looks better. So this, as I said, a kind of programming language, really. It's very Java-like, but it's all interpreted at runtime. So there's no compilation process or anything involved. You can just store these files, and they are immediately reloaded and used. So just as one example that I would like to show is this rule here, the timer demo, which is more or less a staircase light rule. So you can turn on the light, it stays on for a while. It stays on even longer if you press then or somewhere in between this period again, and you can also turn it off. So that's, for the user, a quite easy feature, but actually to implement it, you need already quite some complex logic to achieve that. And just to go through this one here, you see that the rule says it triggers when the item corridor ceiling light received a command. Then if this command is on and we don't have any timer yet, then create a timer to say now in 10 seconds, send a command to turn it off again. So that's really a closure here that we can define. So some code that is going to be executed in a job later. If there was already a timer, then please reschedule that one to in 10 seconds and not execute it whenever it would have ended. If we have a command off, then cancel every timer and just say, okay, the light is off. So we're not wanting to receive another off later by the timer. So that's a kind of rule here. We can actually check if that works by navigating to our light in the ground floor corridor. And if we turn on the light here, we should actually see that 10 seconds later that turns off again. Meanwhile, there we see it's off again. Wonderful, it works. So meanwhile, let me go back to the paper UI here, and I'll show you now the graphical rule engine, which is the entry here. And we can say, let's create a new rule, demo rule, let's give it some name. And we can likewise say when some, that's a very rare bug that sometimes happens. Sorry for that. Actually, the best plan to do that is just to restart the runtime. So logging out takes a moment and we're starting it again, and then this should be back again. That's why the graphical rule engine is still marked as experimental. It's not fully stable in all situations yet. Okay, getting back the log, going to our rule, not yet started. Okay. So we're back here, creating a new rule, demo rule, when that looks much better now. So you see we have different things to react on. These are the so-called trigger types. And we can say that if some item state changes, we want to trigger something. And why are there no items now? That's also, it's not my lucky day for the live demo, as it seems. Maybe we need to refresh it here. Item state changes. We don't have any items here. Can we do something else? Fixed time of day, that's a bit difficult to do. No, I would need that. There we go. It was just some hiccup, as it seems. So let's say we use a different light in the first floor child room ceiling. If that one switches to previous state, if it switches to off, then our rule should trigger, demo rule. And for example, we could now say, well, if the light is turned off, we could say good night to our kid. Good night. Okay, we could now also say, well, only do that if it's a certain day of the week, doesn't work, but yeah, if we have a certain time of day, for example, so only if it's late in the evening to say goodnight, because otherwise it might not make sense. But let's stay with that. We can test the rule here.
Good night.
Okay, so that the actions actually work. You see that that came out here. And now let's see if that rule works. If we go to our first floor, child room, we have the light on, we turn it off.
Good night.
And we see it flickered here, it was running, and it's immediately
good night
working here. So that's really the easy part here. You can, of course, chain a couple of things. You can also trigger other rules here. You can also, if you say, well, okay, graphical is nice, but you still want to do some kind of programming, we have the possibility to actually execute JavaScript code in here. So it's quite powerful what you can do within these rules here. Okay, so that much about the rules. Let me just see, right, the last thing I want to show you is the hub panel as a user interface. which is quite neat because you can really set up a lot of different widgets here, controlling them, switching. It's really more as a big control panel for bigger screens somewhere. It has also very nice charting features, and Hub Panel is the only UI that doesn't rely on the sitemaps, but where you can actually directly edit the content within the UI itself. So we could go here and say, well, let's edit that one, use a different item, change the font size, change the icon that we want to use, all kinds of things. So you can really click it together the way how you want your UI. Just to give you an idea about the charting possibilities, I'll briefly go to my very own personal openHAB instance that I'm running at home. And let's have a look at the hub panel here, where I'm having actually some energy panel set up with that, which is a nice demonstration. So this actually shows you a couple of item values at the very same time on one chart. The blue line shows you the elevation of the sun, so where this was over the day. Yellow is the photovoltaic power that has been actually produced by my photovoltaic system. Red is from my local weather station, simply the brightness of the sky. So you can really see that this should be aligned all the time. Otherwise, you might have an issue with your system. Green is the day temperature that we had today. So you see it was a warm and nice sunny day here. Down here you have the same over the last week, and yeah, it's really very powerful and neat to really monitor your things and have an idea about the historic states and what's going on. So that much just as a brief insight into my very personal setup here. Last but not least, let us have a look at the REST API, just to show you that, for example, the rules that we've just created, we can retrieve through the REST API. We can interactively try that out, and we see what we've just created. So we have a rule with a trigger item state changes, which reacts on the child ceiling when it goes off. We have an action, say something, good night, and the rule has a name, no further configuration. So you see that all that we've created through the UI is a pretty simple JSON data structure. And you can now also go build your own user interfaces for rules, for example. Simply create that, update that, and model that. And that's, of course, not only available for the rules. You have on the sitemaps available, the things, voice support available here, the interpreters available, all kinds of different things. You can check what's still in our inbox, and also this, the Fritzbox or NTP local time. All of that is just a basic JSON structure. So it's really open, extensible, and you can do a lot of stuff with that. And with that, the demo time, I think I'm at the end of my demonstration, and we can come to the Q&A section. Thank you very much for your attendance so far. So,
thank you so much for the very interesting presentation, Kai. Let's have a look if we have any questions from our participants. Okay. Can you see now the Q&A tab from your computer, Kai?
Yes, I can see. I can see first question from Radek. How can I connect multiple microphones in different rooms to one Raspberry Pi with openHAB server? That's a good question. So well, you would need some remote device that is supported as a binding in openHAB. So far, microphones are not yet supported by most of the bindings. So far, most people are concentrated on having audio sync, so being able to play stuff. I think there are mainly frameworks like Pulse Audio and other things where you can actually use audio input. And I think these things should work well then as an audio source. But at the moment, unfortunately, there's no direct support for such a setup available. Okay. Next question that I see from Timur Schenkau. Two questions actually. First one, what is the license of openHAB? Well, that's easy to answer. The license is the EPL, the Eclipse Public License, which is a weak copyleft license, which means that it is quite friendly to also be used commercially. So it's not viral like the GPL, for example. And yeah, as openHAB uses underneath Eclipse Smart Home as one of its core libraries, which is under the EPL itself, that's more or less the most natural choice here. The second question here was, would it cope with 1 million messages or devices emitting 1 message per second? Oh, wow. I would be interested what kind of smart home setup that exactly is, but I think there is no general answer to that because it will very much depend on the hardware where you're running openHAB on, I guess. I've actually heard about installations in industrial setups on bigger installations where people track their machines for their data. And they told me they actually processed millions of messages per hour through openHAB on that system, running on not too big servers actually. So in general, I would say yes, as openHAB internally uses really an event bus, which is quite powerful and doesn't have a big overhead for every single message. You can send quite many messages through it. The downside will probably be mainly then what do you do with the messages? If you're exposing them through SSE to some outside listener, then your REST API might be bottleneck. If you want to persist them to a database, your database might be a bottleneck, and so on. So it very much depends on your personal setup, I guess. Next question from Alvaro Martinez. Can I get Kai's email? Well, everybody can get my email. It's very simple. It's kai@openhab.org. So if you want to reach me, you can do that. But in general, I would say I prefer that you go for questions actually to our forum, which I had here on the last slide, which is https community.openhab.org. That's actually where all information about openHAB is exchanged. And usually, if you try to contact me, my response times are pretty low because I simply have too much to do. But on the community, you find many people that are really helpful and which reply immediately to many things. So that's definitely the best way of getting support around openHAB. But if you have to discuss something privately, feel free to reach out to me, of course. Okay. Any other questions?
Looks like not at the moment, or at least I'm missing something. No, checking the Q&A, checking the chat, I guess that you have answered everything, right?
I tried so, yes.
Kai, thank you very much. On behalf of Luxoft, on behalf of myself and the LTS program, I would like to thank you for the very interesting webinar, the very interesting presentation. I believe that every participant who joined today's webinar enjoyed that as much as I did. I would like also to thank all the participants who could make it today. Once again, you will get the link with the recording of this webinar, and I would also like also to ask you to fill in a little opinion poll on the webinar that you've listened today. This would help us to improve in case we need to improve in future and make our webinars even more interesting and user friendly. And also definitely follow us on Facebook and LinkedIn and Twitter to learn about coming events. Kai, thank you again.
It was my pleasure, and thank you everyone for listening. Bye-bye.
Thank you. Bye-bye.